This carbylamine reaction is used for the identification of primary amines. This carbylamine reaction is only given by primary amines. Then what actually happens when a primary amine NH, this is going to be a primary amine. This primary amine, when treated with, can anybody tell me what is the name of this compound? CHCl3. What is the name of this compound? Chloroform. Very good, very good. In presence of potassium hydroxide. In presence of potassium hydroxide, they will form a compound which is known as alkyl isocyanide. This is going to be the compound, and it is identified. It is identified with what I meant to say. It is identified with its characteristic order. It is identified with its characteristic order. ఎలా ఆర్డర్ ఉంటుందంటే దీనికి అసలు మనము భరించలేనంత బ్యాడ్ ఆర్డర్ ఉంటుందన్నమాట. See, whenever it is a what I meant to say, whenever it is going to be this is going to be formed, and in this case you will get a characteristic unpleasant order. Instead of I'm saying bad order, you say unpleasant order. You can't bear that order itself. Okay, now you balance this equation. How to balance? You try to balance this one. Simply I will say only one thing. Whenever a primary amine is treated with the chloroform in presence of potassium hydroxide, it will give a compound that is called as isocyanide. This is called as isocyanide. Okay, and it is a what is called as unpleasant order. It has having unpleasant order characteristic, some unpleasant order. ఇప్పుడు మనము ల్యాబ్ లో ఇది కూడా చేస్తాము. యాక్చువల్ గా ల్యాబ్ లో ఈ ఎక్స్పెరిమెంట్ కూడా చేస్తాం. You are provided an amine and you are asked to identify whether it is a primary, secondary or tertiary amine. In such cases, what you will do? First, the given compound you taken in a test tube. Okay, let us. I'm taking. Can anybody tell me what may be the name of this compound? What may be the name of this compound? This is called as aniline. This is aniline. Aniline. When aniline is treated with, what is that compound? One is said to be the chloroform. One is said to be the chloroform, and another is said to be the what is now another is going to be the potassium hydroxide. Simply what happened, and this aniline is converted into phenyl isocyanide. This is going to be the phenyl isocyanide. This has having very, very unpleasant odor. Even you are unable to stay in the lab itself with this because of its smell. Phenyl isocyanide. And this test is used for the identification of what is called as the primary amines. This is what is called as the carbylamine reaction. What is carbylamine reaction? Carbylamine reaction is used for the identification of primary amines. So only the primary amines will give the carbylamine test. In this carbylamine test, to given amine, chloroform and a KOH is added, and that will immediately give an unpleasant odor in which an isocyanide is formed. With its characteristic odor, we can say that it is a primary amine. Of course, if it is a secondary or tertiary amines, they won't give this unpleasant odor or a isocyanide. That's why we can say the given compound is isocyanide. For example, when aniline is treated with the chloroform in presence of potassium hydroxide, a phenyl isocyanide is formed, which is having its characteristic unpleasant odor. With this, we can identify what we call it as the, what it is, carbylamine reaction. With the help of the carbylamine reaction, what will identify? Primary amines. So only the primary amines will give this test. Okay, this is what is the carbylamine reaction. Now what I told you, the next one is going to be the Hinsberg separation. How to separate? Suppose what happened in the case of what you call it as the in the case of what I meant to say, are you getting this slide? Slide వచ్చిndamma?
Ochindi sir. Ochindi
Okay.
sir.
What is there in the slide? Can you read the heading on the slide?
Hinsberg test.
Hinsberg test. This is used for the separation of amines. Suppose in a given compound or in a prepared compound, suppose if it is a mixture of primary, secondary and tertiary amines are there. In such cases, how they are separated? And that can be separated by a test, which by a method, or by a test which is called as Hinsberg test or Hinsberg method. What is there in Hinsberg method? See, if it is a primary amine, what happened in primary amine? Nitrogen contain 2 hydrogens and 1 alkyl. Then in this is going to be said to be Hinsberg reagent now. Now benzene sulfonyl chloride is a compound, and when it is added, because there is 2 hydrogens, what happens here? The hydrogen from here and chlorine from here will be removed in the form of HC. So that what happens? The nitrogen is directly bonded to the benzene sulfur which is present in benzene sulfonyl chloride. Now, because here it is in hydrogen, you see here, because it is a hydrogen, where this hydrogen is having some what is called as acidic nature, and that can be dissolved in sodium hydroxide, and that's why it is forms a sodium salt, because this hydrogen is removed in the form of water, isn't it? This H and this OH will be removed in the form of water, and you will get a soluble salt, which is called sulfonamide salt of sodium. Then suppose if it is a secondary amine, what happened? There is only 1 proton, whereas here it is 2 proton, you remember, whereas here only 1 proton. The difference between the primary amines and secondary amine. Now this also reacts with this chlorine. Now it is eliminated in the form of HCl. So that what happened? The sulfur of sulfonyl chloride, benzene sulfonyl chloride, will make a bond with the nitrogen. You remember here there is no hydrogens, isn't it? There is no hydrogens. Therefore, it won't react with the sodium hydroxide. That's why you will get here insoluble in aqueous sodium hydroxide, and N-dialkyl benzene sulfonamide is formed. This is soluble in aqueous NaOH, whereas it is not. Suppose if you go for the tertiary amine, you see here there is no hydrogen. There is no hydrogen. Therefore, it won't react here like directly, because there is no hydrogen like this to eliminate NaOH. That's why directly it react with the sodium in presence of sodium hydroxide. Directly they react together and forms salt of benzene sulfonic acid, which is also insoluble in NaOH but soluble in HCl, because it forms a quaternary salt. It forms a quaternary salt. And here this is going to be the, see here, what is the difference here? In this way, primary, secondary and tertiary amines can be separated. First of all, benzene sulfonyl chloride is added, to which NaOH is added. If it is soluble, the soluble product is going to be the primary amines. If it is insoluble, it may be a secondary or tertiary amines. Okay. In the case of the secondary amines, the NaOH is it is insoluble in NaOH, so that this primary and secondary can be separated. How to separate the secondary and tertiary, and the remaining solution is treated with the NaOH, so that you will get salt of benzene sulfonic acid. And here again, this is amine, some reactant is remains in the solution, that's why it is soluble in HCl, and so that you will get this what is called as ammonium salt in this way. And here if you see either primary amine or secondary amine, these two are insoluble in HCl, you remember, because they won't form tertiaries, that is quaternary ammonium salts. The quaternary ammonium salt is formed only by the tertiary amine. That's why it is soluble only in hydrochloric acid, whereas these two are not soluble. In this way, from the mixture of primary, secondary, and tertiary amines, the amines are separated by a test or a method called as Hinsberg test. Can anybody tell me what is the reagent used in Hinsberg test? What is the reagent? Are you there? Yes.
Yes, sir.
What is the reagent used in Hinsberg test or Hinsberg method? What is this reagent? This is going to be the reagent.
Benzene sulfonyl chloride.
Benzene sulfonyl chloride is used. Okay, what is the role of benzene sulfonyl chloride in the amines? They react with the primary amine. The product which is formed is soluble in NaOH, whereas it react with the secondary amine, but the product is insoluble in NaOH.
Insoluble.
In the case of the tertiary amine, it won't react with this salt, isn't it? It won't react because there is no hydrogen. That's why benzene sulfonyl chloride won't react with the tertiary amine. But when treated with the sodium hydroxide, it forms salt of benzene sulfonic acid, and tertiary amine remains. And this tertiary amine dissolved in hydrochloric acid because it forms a quaternary salt. In this way, the primary, secondary, and tertiary tertiary amines can be separated. Okay, are you followed this one?
Yes, sir.
If any doubt, you can ask me anyone. ఎవరైనా గాయత్రి, మానస, ఇంకెవరు వచ్చారు, నరేష్, రచన, ఎవరైనా మీకు ఏమైనా డౌట్స్ ఉంటే అడగండి ఈ టెస్ట్ లోపల. వెరీ సింపుల్. కొంచెం మీరు బెంజిన్ సల్ఫోనైల్ క్లోరైడ్ అంటే ఎందుకు గుర్తుండాలి. If you remember that compound, then it is very easy to assign which will react, why they dissolve in NaOH, why they are not dissolved in NaOH, why tertiary amine dissolved in hydrochloric acid. That point you have to remember.
Okay, sir.
Okay, shall I proceed to other reaction?
Yes, sir.
Okay, now other reaction is going to be the other reaction is going to be a reaction with nitrous acid. This is also used for the identification of primary, secondary, and tertiary amines. What is this? Reaction with nitrous acid. What is the formula of nitrous acid? What is the formula of nitrous acid? What is the formula?
Or HNO.
What? This is
HNO2.
HNO2. Generally, we write it as HNO2 as HONO. Why we write HONO? Because HONO means nothing but here N double bond O will be there, and another is like in H2SO4 OH like this, there will be a OH. Is a monobasic acid, and double bond O will be there, and for example, whenever H2SO4 is see here, whenever it is protonated, what happens? You'll get H plus ion, and this nitronium ion will be formed. Okay, NITROUS. See what happens. This is going to be the primary amine. This is going to be the secondary amine. This is going to be the tertiary amine. See, for the primary amine, when nitrous acid is always in cold and acidic condition. Actually, nitrous acid is very, very unstable, and it is prepared by the action of what is called as the um, that is hydrochloric acid on NaNO2. That is what is called as the NaNO2 is nothing but sodium nitrate. And here, when these are treated, and you remember this reaction takes place at 0 to 5 degrees centigrade only. This will be, the reaction takes place at only 0 to 5 degrees centigrade, and you will get the compound is HNO2, and another compound is said to be the NaCl. In this way, whenever the nitrous acid is needed, and in such cases, simply at 0 to 5 degrees centigrade we add HCl to the Na. So that's why we call it as a cold and acidic condition. Cold means 0 to 5 degree, acidic condition means HCl. Okay, whenever the primary amines are treated with this nitrous acid, what is liberated? Nitrogen gas is liberated, and you will get a clear solution. Suppose if it is a 2-degree amine, for this 2-degree amine, nitrous acid when added, an insoluble oil, here it is a clear solution, but here some oily liquid that is called N-nitrozoamine is formed, an oily liquid is formed. It is not a clear solution. Whenever it is oil is there, that is not a clear solution. If it is a tertiary amine, a clear solution is formed, but that is ammonium salt formation takes place.
Formed.
No nitrogen gas is liberated, only the ammonium salt formation takes place. Because you know that tertiary amines always form salts with acids, isn't it? Acids.
Yes, sir.
Okay, let us see. The first one is going to be the nitrous acid is a Bronsted acid. Bronsted acid is nothing but, can anybody tell me what is Bronsted acid? Bronsted acid is nothing but,
Express donor.
very good. Proton donor is a Bronsted acid.
Bronsted
Of
acid.
moderate strength, its pKa value is 3.33. Because it is unstable, it is prepared immediately before use in the following manner. I told you just now. Either hydrochloric acid or sulfuric acid. When it is added, you will get this what is called as the nitrous acid. Just now I told you, you can add either hydrochloric acid or sulfuric acid, but the temperature is maintained at around 0 degrees centigrade. And you will get this one. This is unstable acid, that's why it is prepared in situ. In situ means in the reaction itself. Under the acidic conditions of this reaction, all amines undergo a reversible salt formation. Suppose if it is a tertiary amine, when it is treated with the hydrogen halide, what happens? Here you see what happened. It forms a quaternary salt. This is going to be the ammonium salt, not quaternary. This is going to be the ammonium salt is formed because here there is a lone pair of electron. It accepts the proton because it can donate this lone pair of electron to the proton present in the acid. This can be donated to this proton. That's why you will get a salt, ammonium salt, that is amine salts are formed. This is a reversible reaction, and again this can be dissociated into tertiary amine and HX. This happens with only tertiary amines, and the salts are usually soluble in water, isn't it? And I told you this happens only with the tertiary amines, not with the primary or secondary amines. And that salts will be soluble in water. The reaction of nitrous acid with the primary or secondary aliphatic amines may be explained by considering their behavior with nitrosonium cation, which is the result of nitrous acid, from the nitrous acid. Okay, when nitrous acid is treated with the sulfuric acid, it will give what? A nitrosonium ion and bisulfite. That is like acid base reaction. In this reaction, because this sulfuric acid is a strong acid, it is a weak acid. That's why it acts as a base, it acts as an acid. That's why, and the H plus, this OH minus ions is taken by the H plus ions of the sulfuric acid, and it will be lost in this. And that will be resulted in the formation of the nitrosonium cation, an electrophilic species present in acidic nitrous acid solution. What is this? This is a primary amine. Now this primary amine, when treated with this mixture, what is that mixture? Sulfuric acid and nitrous acid, that is formed by the action of NaNO2 and H2SO4. And that will give the nitrosonium ion. This nitrosonium ion, what happens it forms a salt like, isn't it? ఇందాక మనం HX అనుకున్నాం కదా, ఇక్కడ HX బదులు NO ప్లస్ H ప్లస్ ఉంది అన్నమాట. And this will be lost, a proton from here, and one proton is lost because it is a primary amine, and you will get this nitrosonium compound, and it undergo tautomerization. What is tautomerization? We have discussed many times. The proton is transferred to the oxygen nearest to this, and the double bond is shifted to here. And this isomerism is called as tautomerism. And this tautomerism again take the proton, because the reaction is carrying in acidic medium, takes one more proton, and you will form an OH2 where oxygen will get the positive charge, loss of the proton takes place, and a diazonium cation is formed. And this diazonium cation loses a nitrogen. That's why the primary amines will liberate nitrogen gas, so that we will get, what is that? Alkyl cation. And this cation, depending on the reaction condition, they may give alcohols and alkenes depending on the reaction conditions. In this way, the primary amines liberate nitrogen, and you will get a clear solution. Now let us go for the secondary amines. In the case of the secondary amines, you can see there is only one proton is there. Only one proton, you remember. Whereas in the primary amines, there is two protons. There are two protons. And this will be replaced so that similar, the first step is similar. But you see, the second step, what happened in the second step? There is one more hydrogen is there. Therefore, there is a tautomerization takes place. And this tautomerism is not possible in the case of the secondary amines, because there is no one more proton is here to remove. Because this H and X will be removed, HX is formed. After forming nitrosoamine, there is no other proton on the hydrogen to move to the oxygen and nitrogen to get tautomerization. That's why it does not form a clear solution, and this compound is an yellow oily liquid, and there is no clear solution is formed. Okay. The distinct behavior of 1, 2, 3 degree aliphatic amines is an instructive challenge to our understanding of their chemistry, but is of little importance as a synthetic tool. The SN1 product mixture from 1 degree amines are difficult to control. Means 1 degree amines, I told you that there may be an elimination reaction takes place or a rearrangement. If elimination reaction takes place, that will give the what is called as the alkenes, and they undergo some rearrangement is very common, because in this rearrangement a stabilized carbocation is formed. When branched or primary alkyl groups are involved, the N-nitrosoamines formed from 2 degree amines are carcinogenic and are not generally useful as an intermediate for subsequent reaction. See, what do you understand by the term carcinogenic? What do you understand by the term carcinogenic? Carcinogenic means cancer-causing substances. They are called cancer-causing substances. Now here, this is going to be the aryl diazonium ion, and here this is, for example, with aryl amines, how does this reaction take place? This is going to be the benzene diazonium ion, aryl diazonium ion, which will lose its amine, that is nitrogen gas is liberated, and you will get phenyl carbocation. Aqueous solution of diazonium ions have sufficient stability at 0 to 10 degrees centigrade. that they may be used as intermediates in variety of nucleophilic substitution reaction. For example, if water is the only nucleophile available for the reaction, phenols are formed in good yield. Phenols means benzene having what?
OH group.
OH group. That's good. See this now. This is going to be we are discussed here aliphatic amines. Here this is about aromatic amines. I will write here. Actually, this is going to be the aromatic amines. Here from here onwards, we were discussing about aromatic amines. Sorry. Or we have to write or aromatic amines. Here this is going to be. Sometimes the cursor is not good to write aromatic amines. Okay, you remember simply. Okay, this is for aromatic amines. Okay, now before going to this, I want to take your attendance. 4 members you came. Naresh, Rachna, Gayatri, Manasa. Okay. Now let us discuss this again. See this regarding aromatic amines. Now if water is a product, there is definitely the phenol. Suppose if it is a 2-degree aryl amine, this is going to be the primary amines. Here also the primary amines loses or liberate nitrogen, but what happens in the case of the secondary amines, what happened here, it react with there is no doubt it react with the nitrous acid and nitrosonium ion is formed. 2-degree aryl amines give n-nitrosoamine derivative on reaction with nitrous acid and thus behaves identically to the aliphatic counterparts. Means it is also what is called as the, what is that, yellow oily liquid, and you won't get the clear solution. Suppose if it is a tertiary amine, depending on the ring substitution, 3-degree aryl amines may undergo aromatic ring nitrosation at sites ortho or para to the amine substituent. The nitrosonium cation is not sufficiently electrophilic to react with the benzene itself or even toluene, but highly activated aromatic rings such as amines and phenols are capable of substitution. Of course, the rate of reaction of nitrosonium and directly at nitrogen is greater than that of the ring substitution as shown in the previous example. Once nitrosated, the activating character of the amine nitrogen is greatly diminished. Diminished means decreased. And n-nitrogen derivatives or indeed any amide derivative do not undergo a ring nitrosation. Actually here, in the case of the this 3-degree aromatic amines, what happens? When it is treated with the nitrous acid, instead of forming here nitrosonium ion with nitrogen, the nitrosonium ion attacks on the benzene ring. And when it is after attacking on the benzene ring, the what is here? The reactivity of this nitrogen will be decreased. That's why there is no further reaction. In this way, the nitrous reaction of the nitrous acid with amines is another important thing, because it is also used to separate or to identify primary, secondary, and tertiary amines. Okay. Now tell me any doubt. Tell me any doubts.
No, sir.
Everena. Then what we discussed till now? What we discussed here? What we discussed today? We discussed one is what is carbylamine reaction. Carbylamine reaction. Can anybody tell me what is carbylamine reaction? What for it is used? What for it is
Primary
used? Very
for
good. It is
primary
used for the identification of the primary
identification
amine.
of the primary amines.
Only primary amines will give carbon-amine reaction. What
Yes, sir.
happened in carbon-amine reaction? Primary amines
And reacts
reacts
with
with the chloroform
chloroform
in presence of
and alcohol.
what? Potassium
KOH.
hydroxide.
Potassium
KOH.
hydroxide.
Then what is the product?
Isocyanide.
Very good. That isocyanide is very, very unpleasant odor. With its
Yes,
odor, you can identify the compound. Okay. Now another what we'll discuss. We discussed about Hinsberg reaction or test or separation. What is the compound used in Hinsberg reaction?
benzene sulfonide.
Very good. Benzene sulfonyl chloride.
Chloride.
When primary amine is treated with the benzene sulfonyl chloride, then you will get an intermediate which reacts with the sodium hydroxide and forms a soluble salt. Whereas in the case of the secondary amine, it reacts with the secondary amine, and that product is not react with any of it. It is not soluble.
No reaction.
That is, it is insoluble in any of it. And what about the tertiary? Tertiary amines won't react with
React with
benzene sulfonyl chloride because there is no hydrogen in
no
tertiary amines,
hydrogen.
and that's why they won't react. But with the sodium hydroxide, the benzene sulfonyl chloride will form sodium salt of benzene sulfonamide, and the tertiary amine will dissolve only in HCl with the formation of the salt. It is not soluble in any way. That is what is called as the Hinsberg test. Now let us go for the another. I told you what is another reaction with nitrous acid.
Nitrous acid.
What is how to write this compound? You can write HONO or HNO. Can you tell me how does amines react with nitrous acid? Primary amines react with the nitrous acid to liberate nitrogen and form a clear solution. Okay. Whereas secondary amines react with the nitrous acid, they won't liberate nitrogen, they form an oily liquid. Whereas tertiary amines won't react with this one, but they form the quaternary salt, and that salt is dissolved in sodium hydroxide. Okay, and in this way, that is going to be here. I'll show you. Okay, remove this annotation. And see here, this is going to be the in the case of the secondary amine. This is okay. Here, this is going to be the primary amine, secondary amine. In the case of the tertiary amine, the first starting only we discussed here. In the case of the secondary amine, see tertiary amine, this is going to be the cold condition. A clear solution is formed. Only the ammonium salt is formed. Okay, and in this way, that is today we discussed mainly what is called as a mainly we discussed about what we discussed, how to identify primary, secondary, tertiary amines, then how to